Welcome to Siren Triple YouTube channel. Let us discuss Module 1 representation of power system components. In that we have a induction motor. I think you might have got a confusion, right? And doubts. So how the induction motor is related to power system components or power system analysis. Before itself I said if you are producing the power, generating the power without utilizing, no use, right? So power system, we have four parts. One is generation, transmission, distribution, and then utilization part will be there, right? So in that we have a induction motor. So this is a utilization part. So it's a consumer side part, right? So induction motor or three-phase induction motor. So the name itself indicates motor which converts electrical to mechanical, right? So working principle is Faraday's laws of electromagnetic induction. That's why we can call it as induction motor. So because Faraday's law will be there, induction principle will be there. That's why it's a induction motor. See, I'll be just giving another one in comparison. So induction motor is also called as a rotating transformer. I think the same equivalent circuit diagram we discussed in the transformer also, right? So similarity will be there, working also similarity will be there. Only the difference is here rotating, there it is a stationary in the transformer, right? But here the rotor is rotating. Just I'll go through transformer. Transformer supply is given to the primary side, induces EMF in the secondary side due to mutual flux linkage from primary to secondary. So the path is core, right? Core is providing the path for mutual flux linkage. Similarity in the induction motor, supply is given to the stator. What happens? So three phase supply or a single phase supply produces three rotating magnetic fields. The stator periphery. So those conductors are the flux produced by the rotating magnetic field speed like 1s ns is equal to 120 f by p, right? So if suppose rotor bar conductor, rotor is present in the bar conductor present in the rotor, so what happens? Cuts that rotating magnetic field, induces EMF. So if suppose EMF induces current, obviously you will get it, right? So when current carrying conductor placed in a magnetic field experience a force according to Faraday's laws of electromagnetic induction. That's a working of a three-phase induction motor, right? So supply is given to the primary, induces EMF in the secondary side due to mutual flux linkage. In the transformer, in the induction motor, supply is given to the stator. Stator produces rotating magnetic field. That rotating magnetic field cuts by rotor. Rotor start rotating when conductor carries a current. When conductor cuts the magnetic field, induces a current, right? See here, induction motor magnetically coupled, electrically separated. You just go through the DC generator. There we have supply we are giving to the stator armature conductor. Then the DC motor. Okay. Then the rotor start rotates. But here we are not giving supply to the rotor armature conductor and only the rotation like a miracle. So just it will rotate like this without having a power supply. Just we are giving power supply to the stator. It's a air gap is present in between, right? So start rotates. That's a induction motor working, right? So here there is a internal circuit diagram of induction motor. This is a supply voltage, okay, and supply voltage, and we have a supply voltage Vs, and this is a stator impedance. Rs is a stator resistance, Xs is a stator reactance. This is the magnetizing components, okay, reactive component, magnetizing components will be there, and this one is a rotor resistance, rotor reactance. This one is a slip, right? Slip is like a relative motion between rotating magnetic field and rotor actual speed. Ns minus nr divided by ns. Ns minus nr is the slip speed. Difference between slip synchronous speed and then rotating magnetic field speed and then rotor speed divided by ns. That's a ratio we are taking. That's a slip. Slip. See here, don't confuse about slip or induction motor working. Slip is a relative motion between that rotating magnetic field, right? Whatever ns is rotating inside the stator periphery, that is ns. That difference, that ratio, relative motion between rotating magnetic field and then rotor speed, right? Mechanical output. So this is a K square or K will be there, turns ratio of induction motor. Similarly, same as a transformer, N2 by N1 or this one is VR by Vs. See here, their transformer induced voltage V2, but here also induced voltage ER or E2 in the rotor side. Supply is given to the primary side is E1. Similar turns ratio, K is equal to N2 by N1, same here also, and V2 by V1. V2 is the induced voltage in the secondary, V1 is the primary induced voltage or primary supply voltage, and N2 is the secondary turns of the induction motor, and then N1 is the stator field winding turns, right? So the next concept is where we are using a induction motor and the real applications, right? So induction motor at present we are eliminating all the DC motors in the industries, because induction motors having more advantage, and then efficiency also more, and then losses will be less. Just to compare with the DC motor, there is a commutator segment will be there, brush contact will be there, so many losses will be there in the this one DC motor. But in the induction motor, there is no losses. 90 percentage of the motors always like squirrel cage motors in the industries. And even though in our now a summer season, right, so the fan will be there, right, that is single phase induction motor. So and also the heavy applications like lift, crane, elevators. Basically we I mean like 10 years back we are using this one DC motors, but present induction motor, because its supply is readily available, so directly we can utilize, and also efficiency is more, and there is no I mean minimum loss will be there. So induction motor we are preferring, even though for elevators and lift, and also lathe machine, drilling machine, and but don't confuse that this one mixer grinder they are using universal motor. It operates both AC and DC. Okay, that is one type of AC motor or DC motor, universal motor. So that's the induction motor application. Even the induction motor using in normal domestic appliances like lifting of water from the um, bottom to top floor, right? I mean tank will be available in the top floor. There also we are using induction motor, right? So that's a concept. This is a circuit diagram for induction motor. So in the power system operation or power system components, so see here there is a generator, and here to here transmission will be there, distribution will be there. This is a motor. Okay, output side we are using motor. That's a concept we are going to discuss in the later classes, right?